Today's notes are on how to rationalize the denominator. So again, this might be something, or it should be something that you went over in Algebra 2. So we're just going to look into it again, maybe extend on what you learned in Algebra 2 a little bit. So the first thing is example 1. It says rationalize the denominator. The reason we have to rationalize is because if you remember back to yesterday's lesson, in order for it to be considered simplified, all fractions have to have radical-free denominators. Okay, so radical-free denominators, meaning we're not allowed to have that radical in the denominator. So what we do is we just make an equivalent fraction where it doesn't have the radical in the denominator. So to do this for this first example, we want to multiply by the conjugate. So that meaning if I have a square root of 3 in the denominator and I want to get rid of it, I'm going to multiply both by the square root of 3, both numerator and denominator. So we're multiplying by a 1 value. So we multiply fractions by multiply straight across, so it's going to be 5 times the square root of 3. And then if I multiply this, I get 2 times the square root of 9. Now if we go through and simplify, 5 root 3 stays there. 2 square root of 9 is 3. So now if I continue to simplify, I get 5 root 3 in the numerator all over 6. And that's our answer. So 5 root 3 over 6. All right, so the reason they canceled here, let me go back. The reason this right here went away is because I really had the square root of 3 squared. So my exponent and my index were the same. So therefore they canceled each other out. We need to remember that for B, because for B, I see a radical, and this is what a lot of people want to do. They want to say, okay, I want to multiply by square root of 5, because they see a radical. But if I do this, look what happens in the denominator. I can't really multiply these two things together because they don't have the same index. So then people say, okay, I'm going to put a 3 here and a 3 there. Great, we're at least on the right track, but let's work this out. So maybe don't write this down though. So we have 2 times the cubed root of 5 in the numerator, and then the denominator I have the cubed root of 5 squared. So now if we look at this, we run into a problem because my index and my exponent do not match. So because they don't match, I still have that radical in the denominator. So in order to fix that, we have to make them match. So if I have an exponent of 1 here, how many do I need to have? I need 2 more. So that's what I'm going to do here. I'm going to multiply both numerator and denominator by the cubed root of 5 squared. So if I multiply straight across and simplify that, the numerator becomes 2 times the cubed root of 25. The denominator, I get the cubed root of 5 cubed. So the cubed root of 5 cubed, you could do 5 cubed and get 125 and then take the cubed root of that, but we're going to end up with 5 because those two cancel. So we have 2 times the cubed root of 25 all over 5. And now let's think, can we simplify the cubed root of 25 in the numerator? Or can I reduce my whole numbers, my 2 and my 5? And the answer is no to both of those questions. So we're finished with this problem. That's all we can do to simplify. Moving on to example 2, rationalizing the denominator. All right, so again, we have to multiply both numerator and denominator by the conjugate. So in this case, since we have an expression, we want to multiply both numerator and denominator. Since it's 3 plus the square root of 7, we want to multiply by 3 minus the square root of 7. And the reason we do this is because I now have a binomial times a binomial. So if you think back to the last lesson we did, we had to FOIL this. Well, because these are, opposites, it's called the difference of squares, if you remember, that it's going to actually end up working out to our benefit. So I'm going to write this one out the whole way, but just know through the process, those two middle terms when we do our FOILing process are always going to cancel. So taking this step by step, the numerator, I get 2 times the quantity 3 minus the square root of 7. Now the denominator. I do my first two, so 3 times 3 is 9. I do my outside, so that's minus 3 root 7. I do my inside, that's a plus 3 root 7. And then my last two, that's a minus square root of 49. So if you notice, my center two terms are opposites, so they cancel. That will happen and should happen every single time as long as you multiply by the right terms. So now simplifying, I get 2 times 3 minus the square root of 7 all over 9 minus the square root of 49, which is 7. So if I keep going, 2 times 3 minus the square root of 7 all over 2. Hey, my 2's are going to cancel because we simplify them just like we simplify all of our fractions. So our final answer is 3 minus the square root of 7. We'll do another one of these together. All right, let's look at B. Again, I say, oh, I see a radical in the denominator. We do not like that there. There is subtraction. So I'm going to multiply the numerator and denominator by a special 1. So in this case, it's 2 root 5 plus 4. Okay, we only change the sign, that middle sign. So 2 root 5 plus 4. So my numerator is 3 times the quantity, 2 root 5 plus 4. Now my denominator, I'm only going to write the first and last terms. So I'm going to have 2 root 5 times 2 root 5 minus 4 times 4. Because remember, my two inside terms will be negative 4. Actually, I'm just going to write it out. It'll be negative 8 root 5. Those two terms there is going to be plus 8 root 5. So they're going to cancel, and that's why we're left with that. So simplifying here. So actually in the numerator, I'm going to go ahead and distribute that 3. So I'm going to get 6 root 5 plus 12 all over, simplifying this denominator. I'm going to get 4 times the square root of 25, which is just 5. So 4 times 5 minus 16. So in my numerator, I see a 6 and a 12. So I'm going to go ahead and factor out a 6. And we're left with the square root of 5 plus 2. All over 20 minus 16, which is 4. And now notice, hey, I have a 6 and a 4 as a whole number. So I can reduce that. So they're each divisible by 2, or yes, by 2. So I have 3 times the square root of 5 plus 2 all over 2. And now, please do not do what some people do. Some people look at this and they say, oh, there's a 2, and they cancel them. Okay, we cannot do that. That 2 in the numerator is being held to that square root of 5 by an addition sign, so we cannot cancel them. So we are done at this point. Now, there's a couple things you might be wondering. You might be saying, well, Miss Hager, why did you have to distribute that 3 through? It's not necessary. I could have just factored out a 2 here from each of those. But the reason I chose to do that is because I know from in the past some students make small mistakes with that. So I found it easier if I just show you to distribute it and then factor one thing out at the end. You're less likely to make a mistake. Also, you do have to factor out the number before you can simplify. It's not 100% necessary. We could have done this. But then what a lot of people do is they will simplify these two, or they'll simplify these two, but you must simplify all of them if you're going to do that. And a lot of people forget that. So that's why I'm going to say let's factor out a number and then reduce, so that we don't make those careless mistakes that are common. Okay. We have one more example to go over, and it's going to seem like the complete opposite of what you ever wanted to do, because we've been sitting here talking today about simplifying radicals means no radicals in the denominator, and this last example is going to say we want you to rationalize the numerator. So it's telling you to put that radical that you just got in the numerator back into the denominator. And actually this is useful when you get to maybe trig or calculus a little bit, so that's the whole purpose. So just because they're asking us to do something that looks different, it is still the same process. I'm going to make that into a multiplication. So just because it's the square root of 5 minus the square root of 7, we're going to do the square root of 5 plus the square root of 7. And we need to do that to both numerator and denominator. So now, multiplying straight across, square root of 5 times square root of 5 is the square root of 25. We'll write this out. My inside terms are negative. Well, I'll go ahead and write all this out. Negative root 35. My outside terms, I know I did that backwards, is positive root 35. And my last two terms are negative square root of 49. The denominator is 2 times the quantity square root of 5 plus the square root of 7. So, simplifying a whole bunch of stuff in the numerator. Positive and negative root 35 cancel. Square root of 25, that is just 5. Minus square root of 49 is 7. Denominator stays the same. Alright, so now the numerator, I can reduce that to a negative 2 all over this. And hopefully right away you're saying, hey, there's a 2 in the numerator, 2 in the denominator. So let's go ahead and reduce it. So our final answer, we're going to get negative 1 all over the square root of 5 plus the square root of 7. And we're all finished.